So, good morning, friends. Today we are starting with a new module of energy management in commercial building class, and this module is steady state building load calculations. So, it's going to be steady state building loads. And to start with this, let's understand the intricacies of this. We are first of all saying it is as steady state, and we know it's not steady state in actual situations. The weather conditions keep on changing, and hence the steady state assumption goes away over there. We are absolutely wrong, but a steady state load calculation gives us a fair enough of idea of how much is an estimated heating or cooling load of a building. And the building loads, it says what are the different kinds of building loads which majorly act on our building and which will lead to a cooling or heating requirement. So to start with the module, uh, I have introduced you with the problem with steady state and the assumption of steady state. The use case of steady state load calculation is, even though we are having a very little amount of data, less amount of computation to be done, and we can get a fair amount of idea of estimated heating or cooling requirement of a building for a month, for a week, or a year. And hence, since it is not a dynamic simulation kind of model, we should not use it to the steady state building load calculations to estimate the amount of peak load. So it's not useful for peak load calculations or to size our equipments. This will absolutely go us wrong if we use steady state building load calculations to estimate the peak load or size of equipments required. So we should restrict ourselves to getting a basic estimate and see the accuracy of our model. That's the only requirement, and that's the only use case of steady state. And now to start with, the major type of loads which we are going to cover will be, there are four major type of loads, starting with the transmission, the second being solar, the third being the occupants, and the fourth being the electrical. And we can group them in different ways. We can group them this two as a single thing, we can group these two as a single thing, and it doesn't matter a lot. What our focus is to individually look at the expression to estimate the amount of solar load or estimate the amount of electrical load, transmission load, and all. So inside the transmission load, what's included is, or what does this mean? It's the transmission through walls, roof, and floor. Sorry, I'm using this the first time, so please bear with me. Sorry. The solar load, which I have mentioned over here, will take into account the windows and the doors. Basically, the focus is to estimate the amount of heat transfer happening through the glass area. That's the thing included in the solar load, glass area. And how are these estimated will be covered in detail later on. These two as a combination are our internal gains, internal load, and definitely this will always lead to internal gain, heat added in the building. The solar will always give us heat gain, while the transmission depends. It depends on the two things. Depends on, first, it depends on the comfort. Basically, the temperature set indoor, and second, it depends on the weather, which basically means T outdoor or the ambient, right? So if my indoor temperature is higher than the outdoor temperature and like we want it to cool, then it is heat gain from the outside and the things will change. So let's come back to the occupants. For the occupants, we are going to take into account the sensible load from occupants and the latent load from occupants. And I sincerely hope that you know what the meaning of sensible heat load and latent heat load is. We have already discussed this earlier. And this will now depend on the activity people are doing and number of people, right? And we'll go into explicit expressions for the amount of sensible heat gain and latent heat gain due to occupants in upcoming videos. For the electrical, we'll just estimate the amount of equipments we have, if equipments used, right? And we'll have maybe the watt or BTU per hour expression for them and the amount of time they are used, duration. And this is the basic thing for us. We'll now in the next upcoming videos we'll go into the individual transmission loads, solar loads, occupants. Inside the transmission there's another factor also. This is the transmission load which is due to these two conditions of weather. That means the temperature difference between outside and indoor. But there's another factor also coming up, and let's just briefly look at that one. The other one would be the solar transmission. And what does this mean is, it's due to the solar load on non-glass area. So all the solar load on the glass area is considered under this solar factor, but obviously that solar load is also there on our walls and roof. So we need to take into account that solar load, and because of that heating of the walls and roof due to this solar load, the solar radiations, that will also cause a little amount of load on our building. So we'll now go into more details of each of these loads individually, how their expressions are, what are their factors dependent on and all. So that's how we'll pause over here. Thank you.